Welcome back, class. So today we're going to be talking about rate of change. And so this really should be a lot of review, but we're going to take it from the top. So here's our first key concept. As we ride a bike up a hill, both your vertical distance, the rise, and your horizontal distance, the run from the bottom of the hill, change. And we can measure that steepness of the hill by its slope. And so we're going to call this a rate of change. Notice how we talk about change. And so our slope is rate of change. Rate of change equals slope. And we've interchanged those words several times in lessons that we've been doing. And basically what it means is how fast is my line changing, my rate of change. We also know that slope is equal to the rise over the run. So if we look over here in our graph, our rise is 6 and our run is 8. And then we would simplify and we would 2 goes into both, so this becomes 3/4, right? And then another way to think of slope is also our difference in y over the difference in x. And so sometimes we've been writing that as y minus y over x minus x. That's what we mean by difference in y over difference in x. So that's what we're working with in this lesson, which, like I said, is review for us. This is not the first time we've been working with slope. So let's go ahead and get started. Example 1, find the rate of change of the linear function that models the height of the zip line. So here's the start of our zip line. Here's the end of our zip line, right? So those are our 2 points. I'm going to count, right? And if I look at my interval, we're going by 25s. So if I go down 2 boxes, that's down 50, because that would be 25, 50. All right, and then I'm going to go over, right? And so that's 25, 50, 75, 100, 125, 150, 175, 200, 225, 250, 275, 300. So I know that this is a distance of 300. And so from there, my rise is actually a fall, but we're still going to call it a rise of the negative 50 over 300. So rise over run. And then I'm going to reduce. So 50 divides into both of these. So I'm going to divide both by 50. And I end up with a negative, because negative divided by a positive is negative, 1 over 6. And so our rate of change, I'm going to call it ROC, like we did last chapter. ROC is going to be a negative 1 over 6. And that's using the rise over run method. Okay? You could, in a problem like this, also find your points. This would be 0, 250. And this one would be 300, 200. And do your subtraction to find your rate of change. It's really whatever you are most comfortable with. So our next concept is just that, using y minus y over x minus x to find our rate of change. So we have the point -1, and 2, 5. And so we're going to plug those in. I'm going to choose the 5 first. 5 minus -1. So y minus y. And since I chose the 5 first, then I'm going to choose the 2 first. 2 minus the other -1, x minus x. And so minus a negative becomes plus a positive. That happens in both of these. So we end up with plus a positive. 5 plus 1 equals 6, and 2 plus 1 equals 3. And so then we end up with 6 divided by 3, which equals 2. And so our rate of change is 2. Now, if you notice, we also have our equation written here. And so our rate of change is in that slope position. So m equals rate of change. So we can see that in both the graph, find our rate of change, and in our equation. And notice that also in our graph, it did the counting for us. I just wanted us to practice a little bit of the subtraction as we go. So that rate of change is what we call is in the coefficients place for, in the coefficient place, which is the number in front of our variable, or in this case, the number in front of x. So let's go ahead and do an example. So we're going to identify the equation of each linear function shown from the choices given, and then state the rate of change in the function, or of the function. So when we're given equations, right, might as well start with finding that b. So that y-intercept. And in our case, that y-intercept, every 2 boxes is 1. So here's 1, 2. That means that this is sitting at 3. So I know it's not y equals 1/3 or y equals 3x, because neither one of those has a plus 3. So now I need to decide, is it positive or negative? Because both of these have 3. I just have to look at my line now. This is really just a bunch of, is it, process of elimination. That's the word I'm looking for. So when I look at the line, I know that this is a negative slope, because if I were to draw myself a little stick figure person, he's going to go down, and in this case probably tumble, but he's going to go down the slope. And so I know that the equation of my linear function is y equals a negative 3x plus 3. I could also come here and find a second point and count that we are going down 1, 2, 3, and over 1, right? Down 3, right 1. And so we're still finding that slope. And then it says state the rate of change. So our rate of change for this function is going to be a negative 3. And it's not a negative 3x, it is just the coefficient. So our rate of change is negative 3. All right, next example. Identify the equation of the linear function shown from the given choices, and then state the rate of change. So again, I'm going to start with the y-intercept. I know that y-intercepts happen where x is 0. So I'm going to go here. This is where I'm going to find my b value, right? So my y-intercept is 0, which means I can x out the 3x plus 3. I can x out the negative 3x plus 3. And I know that I am at either 1/3 x or 3x. And then from here, I'm going to do some subtracting. And subtracting is from the table is easy. We just need to pick 2 of our points. Any 2 points will do. And if you have 0, 0, that's the easiest point to choose. So I'm going to do 0 minus a negative 2/3. And remember, it's y minus y, right? Y minus y over x minus x. So I'm doing 0 minus a negative 2/3, and then 0 minus a negative 2. And then what I'm going to end up with is minus a negative becomes plus a positive, so we end up with 2/3 divided by 2. And if you remember, when we divide by a fraction, it's easy as pie. We flip and multiply. So where this was 2/3 divided by 2, we're going to make it 2/3 times 1/2, because I'm going to flip my second fraction, which is the 2 over 1. And then 2 times 1 equals 2, and 3 times 2 is 6. And I'm going to reduce, and I'm going to end up with 1/3. So I know that 1/3 is my rate of change, which makes y equals 1/3 x, the equation that matches this table. And I know that my rate of change is 1/3. All right, last example. An employee at a candle making company collected data about the burn time of a new candle. And we want to find the rate of change of the candle's height between the hours 1 and hour 4. And then what does the rate of change mean in this situation? So it's telling us which 2 points to choose. So it's telling us to choose 1, 22. So that's 1 point. And then hours 1 and 4. And so our other point is 4, 13. And so I'm going to start with our second point. I'm going to do 13 minus 22, because I'm going to do y minus y over x minus x, difference in y's over difference in x. 13 minus 22 over 4 minus 1. And then from there, I'm going to do the subtraction, and 13 minus 22 is 9. So we end up with a negative 9 because the 22 is bigger, and 4 minus 1 is 3. 3 divides into 9, so we're going to do negative 9 divided by 3 is going to be a negative 3. And so what this means, our rate of change is a negative 3, and what that means is the candle loses 3 centimeters for each hour it's burned. So basically every hour that we burn the candle, it's going to lose 3 centimeters of height. So however you want to, but it's going to be worded in that way, that the candle loses 3 centimeters for each hour that it is burned, or the height decreases by 3 centimeters each hour, something along those lines. So that is it for rate of change. Again, these are not new skills. The difference in y over the difference in x, or rise over run, is something that we've been working with for a couple weeks now. This is just basically all put into real world situations and between tables and graphs and that type of stuff. So until next time, I will see you there.